Tennis balls are often used to deter birds from nesting in the Hardy Lab. Unfortunately, this causes a buildup of tennis balls that can be hazardous to the people who work in the Hardy Lab. Our team at Hindsight 2020 was tasked with finding a solution that could launch these tennis balls at varying distances and angles into the bins. This would have to be done without the use of electricity or compressed air and could only be triggered by a string. After researching other devices such as tennis ball throwers for dogs and tennis ball servers for practice, there were very few mechanisms that were accurate enough to launch into a can. With the most prominent objectives being the maximization of accuracy and buildability, and our more secondary objectives being the minimization of load time, cost, and weight of the design, the ideation process began. 3 unique designs were created. Design number 1 was a slingshot type device that took advantage of a need for very few parts and the use of an elastic band to store energy. Design number 2 was a crossbow style mechanism that utilized a cylindrical housing for the ball with 2 elastics instead of 1 to increase accuracy. Design number 3 was a mortar style design that had a single central spring and a latch trigger near the front of the launcher. With all designs in mind, we decided to choose a spring-powered mechanism similar to Design 3 due to its higher consistency in output and a trigger mechanism similar to what was seen in Designs 1 and 2, so that the operator may stand behind the launcher and have more variability in power. This design proved to also be lightweight so that it can move easily to be shot from varying distances, and cost-effective because of its small stature and use of MDF in its components that are under less stress. With the prototype built, an issue was immediately run into regarding the trigger. The trigger was redesigned and rebuilt 5 times until it was able to work consistently. The new trigger was designed so that the surfaces with the highest magnitude of force being applied has the lowest possible friction between them. A second issue we found was the difficulty of cocking the launcher. This was solved with the addition of a foot pedal so that the operator may use both hands safely. The main issues that we see in our final design are that it takes over 3 newtons to pull the trigger, and the spring is quite frankly overpowered. But overall, the design works well and will keep our floors tennis ball free.